Hello and welcome to the third and final set on solving a linear system of equations. It seems like the author calls this the addition method. You'll probably hear me throughout the video refer to this as the elimination method because that's what I'm used to calling it. And something tells me in your college algebra class you might refer to this as the elimination as well. I can see the idea behind the addition method because, well, I'll tell you what, I'll let you see here in a little bit. So without further ado, if you have not watched the previous two videos, especially the first one, please make sure that you watch the first one in its entirety before viewing all this video here. So, okay, so let's go ahead and get started. So here we have a linear system of equations, x minus 3y equals negative 7 and negative x plus 6y equals 13. So the idea in the elimination method is to choose a variable and make sure that that variable has the same number opposite signs such that when you add them together, that variable goes away, which then reduces to one equation, one variable, and then we know we're going to go back and resubstitute. So let's take a look at what we have here. So here I got x minus 3y on the left side and negative x plus 6y on the left side. So I'm not going to worry about the right side at this point in time. So let's just notice that the x's here, notice that these guys here have a 1 as its coefficient, and notice that they're opposite signs. The top one's positive, the bottom one is negative. And furthermore, let's notice that if I take a look at the y's, notice that the y's here, notice that this one's a plus 6 and this one's a minus 3. All right, so in order to eliminate the y, I would have to have a 6 in front of both of these. So that means I'd have to multiply the top equation by 2. But since these two, the easiest, since we like to take the path of least resistance, that's our whole goal here, as much as possible, take the path of least resistance, let's just go ahead and eliminate the x, because I know that if I add straight down, notice that x minus x becomes 0x, and notice that negative 3y plus 6y over here, this reduces down to 3y equals, and basically 13 minus 7 is still 6. So notice now that if I solve for y, then I get y by dividing by 3, got to do this, so I get y equals 2. All right, so that means that I have solved and I have a y candidate for 2. So now I have to take this y and I have to pick this one or this one, and it doesn't really matter which one you choose. So I think for this first set, I'll just choose the top equation. All right, so notice when I substitute, I get x minus 3 times 2 equals negative 7. So notice now I get x minus 6 equals negative 7. And when I add 6 to both sides, I get x equals negative 1. So it appears that I have a solution of negative 1 comma 2. And again, I can verify by plugging this back in to both of the equations. So let's just notice that I get negative 1 minus 3 times 2. And I want to know if this is equal to negative 7. So notice that I get negative 1 minus 6 equals negative 7, and negative 7 equals negative 7. So that checks out. So notice if I plug into the second equation, then I get negative of a negative 1 plus 6 times 2. And the question is, does that equal 13? So negative of a negative 1, so negative 1 times negative 1 is positive 1, plus 12 equals 13. And notice that 13 equals 13. So the geometry of this line, of this solution, since I have an x and a y that satisfy this equation, we know that the lines intersect at x equals -1, and y equals 2. So let's just come over here, and let's go ahead and just plug in my ordered pair. All right, so, oops. Don't want to do that. Okay. Breakdown, breakdown. So here we get -1 and 2. Check our answer. Ta-da! We are good to go. All right, so using the elimination method, we would like to go ahead and take a look at 4x plus y equals -9 and 7x minus 3y equals -87. Okay, so here I'm taking a look-see, and I know that I want to add my variables going straight down, and I want one of them to go away. So as I'm observing, I've got a 7 and a 4 here, and they're not really going, it's not going to really do me much good to work with the 7 and the 4, following the method of least resistance. So notice here on the y's, I already have opposite signs. So the only thing I need to do is to get a 3 in front of that y. So what I can do is I can take this whole line here and I can multiply by 3. I can do that. Just take my word for it. You do that because it's okay. Norm said do this. So when I do this, I have to remember to distribute the 3 all the way across, and you'll get into the gory details at another point in time. So it's okay if you just go ahead and do this because there's a rule that says we can do this. So notice we get 12x plus 3y equals -27, and 7x minus 3y equals -87. So notice when I add straight down, I get 12x and 7x is 19x, and notice that the y's drop out. So here I get 14 and I get 11, and this has to be a negative. So now I divide both sides by 19, and when I do that, the 19s will drop out, so I get x equals, and so this is where your handy dandy calculator comes in handy. -114 divided by 19, and I get -6. Okay? I don't expect you to do this longhand. Just pop it in your calculator. Go ahead and do it. All right, so we have 6. So now I have to come back to my original equations up here. Let's clean this mess up a little bit. I don't need that. And so now we pick this one or this one. So I'm going to choose, I don't know, let's choose the bottom one. So 7x minus 3y equals -87. So now we'll substitute into this x right here. So 7 minus 6 minus 3y equals -87. So notice this reduces to one equation, one unknown. So this becomes -42 minus 3y equals -87. And so we'll add 42 to both sides. So on the left side, I got -3y is equal to 545 divided by, so that's -45. So now we'll go ahead and divide by a -3. So here the -3's drop out, so y equals, so this will be a +15. So we get the ordered pair, -6, 15. So we'll just come on over here and check our solution. So I'm going to do the ordered pair. So what do we say? -6, 15. So -6, arrow, arrow, 15. And check our answer. And good job. So again, this means that these two lines, geometrically, these two lines will intersect, these two lines right here, this one and this one, they intersect at the point -6, 15. Okay, let's take a look at this one. So we have 4x plus 2y equals 9, and 8x plus 4y equals 0. Okay, so here, no tricks here. We're just going to have to plug and chug and run and go. So I'm taking a look at the x's. It doesn't matter which one you choose, the x's or the y's, and I'm going to eliminate the x. So I have an 8 here and a 4 here, and so I need the same number, opposite sign. So here it's easy to see that the same number is going to be an 8, but I need an opposite sign. So I'm going to take this top equation and multiply by a -2, because that will give me a -8, so that when I add, the x's drop out. So when I do this, I get -8x minus, so -2 here, 4y equals -18. So here we get 8x plus 4y equals 0. So notice when I add, going straight down, -8x plus that is 0, plus, notice here I add, I get 0 equals -18. So again, I have 0 equals -18. Let's just recall from our previous video, this is a contradiction. All right, so when we have contradictions, we know that the solution is no solution. And let's just observe that this means that geometrically that the lines are parallel. Okay, so now we just come over here, we choose no solution, check our work, we get the OK. Now we move on to the next question. All right. Okay, so now we got our other equation here. So 2x minus 3y equals 2, 10x minus 15y equals 4. Since we did x on the last one, let's go ahead and take a look at y on this one. So notice that the y's, in this case, I got a -15 here and a -3. So again, I got to get opposite, same number, opposite sign. So notice if I multiply the 3 by 5, that will give me the 15 in front, but one of these needs to be positive. So again, why don't I just take this top equation and multiply by a -5. So when I do that, I get -10x plus 15y equals -10. And down here I get 10x minus 15y equals 4. And again, when I add, notice what happens. These eliminate, these eliminate. So on the left, I get 0 equals -6. So again, I get a contradiction. No solution, parallel lines. So we'll check our answer, and notice we got it. All right, let's take a look at this equation here. So we get x over 3 minus y equals 5. Again, back to fractions. Woohoo. So plus 3y over 5 equals -3. All right, so I want to get rid of the fractions. So like we discussed, to get rid of the fractions up top, I can multiply through by a 3. And on the bottom, to get rid of the fractions, all right, denominator, common denominator, I'm going to multiply by 5. So again, I'm going to distribute the 3 along the top to here, to here, and to here. So let's just note that when we do that, I get x over 3 times 3 minus 3y equals 15. And when I distribute the 5 across here, I get here to here to here, which means I get -x over 5 times 5 plus 3y over 5 times 5 equals -15. So notice here the 3's drop out, so we get x minus 3y equals 15. And notice here the 5's drop out, so I get minus x. Here the 5's drop out, I get plus 3y equals negative 15. So notice here it doesn't matter what happens because I've got opposite signs, same numbers across these variables here. Notice that on the left side, no matter what happens, I get 0, and on the right side I get, I think 15 minus 15 is still 0. Okay, so we get 0 equals 0, and this is just like in our previous video. 0 equals 0, a number equals a number. So notice that this means that basically these equations are the same equations. Okay, notice that if I multiply this bottom one through by a -1, I get x minus 3y equals 15, and that's the same as the top. So here we get a number equals a number, so we know that there are infinite solutions, which means that we have the same line. All right. So we just come over here, check this bad boy, check our answer, and ta-da! All right, for my final one, let's take a look at 4x. All right, for our final one, let's take a look at 4x plus y equals negative 15 and minus 12x minus 3y equals 15. So again, hopefully we're seeing that if we take a look at our variable here, it doesn't matter which one we want to eliminate. We already have opposite signs. So notice that if I multiply this top equation here, this one's supposed to be a 5, sorry, negative 5. Okay, we'll just multiply this top row here by 3. So when we do that, we're going to get 12x plus 3y equals negative 15, and minus 12x minus 3y equals 15. And again, notice that we get 0, 0, and here we get 0. So again, 0 equals 0 means we have infinite solutions, that these are the same lines geometrically, and check our work. Alright, so hopefully these videos will help you out when we come back to class. This is all we're going to do for 3 hours. Well, not really 3 hours, I'm kidding. Anyways, let me know how these work out. Thanks a lot.